Let us get started with recursive solutions to things in the linked list, and we'll discuss how and why recursion works. So the basic three rules of a recursion are: the problem must reduce, the function should do some work. You shouldn't pass everything to recursion because the network is based on how much work and what is the type of work you do. So the given function should do some work before or after calling the recursion, and there must be something called a base case, a special case that is so small that it can be solved very easily, but it has to be there inside a recursive function, and the function on multiple calls on reducing the problem, the last problem should always be the base case. These are the three requirements of a given recursion, and we'll see why this works on a linked list. So how is the problem reducing in this case? The problem is reducing when you call on the next node. So the length of the linked list reduces. Ultimately, the length becomes 0 when a null node is passed. So this is how the size of the problem is reducing every time. And then the function must do some work. Now, the working of the function depends on whether you have programmed it correctly and whether it is doing the thing that it is supposed to do. It might be as simple as printing it, or maybe as complex as adding the node to the end of the linked list or somewhere inside the linked list, or depending on the application, it can be easy or complex. And the last case is generally the base case, and that is generally written when your current node or the next node becomes null. So this is the definition of the base case in linked list. So this is the general format that would be followed, and let's just go ahead and see the code structure for a linked list now. So in the linked list, the work has to be done, and we have to make a recursive call to the next node or the next to next node depending on our case, and also there has to be this base case. Generally it would be around being null. All right, so you can look at this skeleton of the code, and this is generally the skeleton of the code that is followed for any recursive call. So once you've understood this, let's understand what is being passed as the parameter. We are passing head of the current linked list. What does that mean? We mean that we are passing the first node of the linked list, and since it contains the next pointer, you can go ahead and take the next things. But look in the line of code here. The input is always a linked list to this recursive function. So in the highlighted line of code as well, you are also giving a linked list. Now, how is that a linked list? Now, that node is also actually the head of a different linked list. This node is being passed to the next one, but the input should have been a linked list, not a node. But if you look at it, it can also be treated head of a new linked list, where the next pointer takes you to the rest of the linked list. So this is how recursion is working. In this case, you're actually getting a head of a linked list that is being passed into the function, and you are getting the rest of the linked list. You are operating upon this head and telling recursion to do the rest of it on the remaining linked list. That is how recursion is working. So let's just create a small function known as reverse print. You want to print the complete linked list in reverse. How can you do that? Well, probably you need an inverse iteration, but you do not have reverse pointers. You cannot go to the previous node using the current node. Now, how to do that? Well, here's an easy solution. I'd like you to identify the base case, the work, and the recursive call in this function. I hope you have understood how reverse print is working, and let's just go ahead, and in the next video we will code the recursive solution for the following problem, checking if two lists are of the same length. Given two heads of the linked list, check that they are of the same length. We will code the solution recursively and see how recursion works in this case. So I'll see you in the next video.